Okay, chemistry scholars, a quick tutorial on ionic compounds. One thing we want to remember when talking about ionic compounds is that these compounds are always made up of a metal and a non-metal. And a great example of a metal is something like sodium. Great example of a non-metal, something like chlorine. Sodium, a metal in group 1, likes to lose one electron, become a positive ion, also called a cation. Chlorine in group 7 likes to pick up that one electron, and in doing so becomes a negatively charged ion, also called an anion. In this case, the metal combines with the non-metal to make a compound called NaCl.
Hello everyone, this is Mr. Park, and I'm going to continue on with this lesson of type 1 ionic compounds. We're going to do the one on the top. The one on the top is, let me just change the pointer.
Press and hold. There you go.
The one on the top is magnesium fluoride, okay? And one of the things that you have to remember is to always use your periodic table to determine the charge of the positive ion and the negative ion. So what I like to do is look for magnesium on my periodic table because it's in group 2. I like to remember that the group 2 metals have a charge of 2+. And then I go over to the right side of my periodic table and look for fluorine. And remember, fluoride is the negative ion of fluorine. And when I look for that, that's in group 7. And so the charge for fluoride would be 1- because all of the group 7 nonmetals have a 1- charge. Then I ask myself, well, how many of each of these ions would I need to cancel out the charges? And I would say that I would need 1 magnesium and I would need 2 fluorides so that the charges would cancel each other out. And after that, I simply write my formula, knowing that I only need 1 magnesium and 2 fluoride ions. The charges end up canceling each other out, so they don't appear in the final formula. And there you have it. Now we'll look at the second example, aluminum sulfide. Remember, look at your periodic table, find aluminum. It's sort of on the right side. It's in group 3A or 13. And you'll remember that aluminum is one of the positive ions, metal ions, that you know the charge of. And since it's in group 3, the charge is 3+. Sulfide, on the other hand, is a nonmetal, so it has a negative charge. It's in group 6 or 16, and so the charge of sulfide is 2- because it needs 2 more electrons to become like a noble gas. Now, once you know the charges, remember, ask yourself, how many of each ion would I need to cancel out the charges? So if I had 2 aluminums, my total charge would be 6+. And if I had 3 sulfides, my total charge would be 6-, right? So 2 aluminums and 3 sulfides cancel out charges, and so your final formula is Al2S3.
Okay, our next compound is copper 2 chloride. What we need to do here is figure out what the formula for copper 2 chloride is. Now the first thing that you might notice is this Roman numeral right here. Okay, that Roman numeral is telling us something about the cation, the metal in this compound. You'll notice that on your periodic tables you can find copper in the transition. It's one of the transition elements. It's still a metal, it still loses electrons, but what we don't know is exactly how many electrons it'll lose. Sometimes it loses 1, sometimes it loses 2. A lot of the transition metals lose a variety of electrons. We just don't know how many they lose. And what we have to do is look at the name of the compound to help us figure out how many electrons, in this case copper, will lose. So using the type of example that we did on the previous slide, what we're going to do here is look at our copper, and that Roman numeral 2 tells us that the copper has a 2+ charge. And going over to the anion, the chlorine there, which is ionized negative, it becomes chloride. Chlorine is in group 7. When it ionizes, it becomes chloride. It picks up 1 electron and now has a negative charge. Okay, so we haven't written our formula yet. The next step that we need to take is to write the formula. Well, let's take a look at our copper. Here, our copper 2. That's our cation. Here's our anion, chloride. Well, let's go ahead and try to balance out these charges here. If I use 1 copper, how many chlorides do I need to balance that out? That'll be 2. So the formula here is CuCl2. That is to say, I need 1 copper, and here it is, which has a +2 charge, and to balance that out I need 2 chlorides.
Hi everyone. Once again, we're going to continue on with our ionic compounds. This time, unlike the previous examples, our negative ion, our anion, it's not something you can find on the periodic table. Instead, it's what we call a polyatomic ion, meaning it's a group of atoms that have a charge. So let's kind of remember what those polyatomic ions were. I think you can look at them on page 130 in your textbook, and I know that there are about 10 of them that we're asking you to know. Sulfate happens to be one of them. And if you look on that chart, I think the formula for sulfate is SO4 with a 2- charge. That's sulfate. It's 1 S, 4 O's with a 2- charge. Calcium is like the other metal ions that we were talking about before. That's on the periodic table. And the charge from calcium can be determined by locating it in group 2 and knowing that group 2 metal ions all have a 2+ charge. So you see, if you have a calcium and a sulfate together, you have to ask yourself, how many of each do I need to cancel out those charges? And you should think to yourself, well, they have the same charge, just opposite signs. So doesn't that mean I only need 1 calcium and 1 sulfate ion so that the 2+ and the 2- charge cancel out? And if you said that to yourself, you'd be absolutely correct. And so if we have 1 calcium and 1 sulfate and allow the charges to cancel, you end up with calcium sulfate, CaSO4, as your answer.